Hi, this is Adam from the classroom. In this video, we will be discussing rounding numbers. Rounding is a term used when we want to simplify numbers. You've seen this before, and more likely than not, you didn't bother reading that number. Complex numbers can be a bother to write and to work with, so we need to learn how to simplify them. When simplifying numbers, we need to choose a target for simplification. So this would be to round a number to a given place value, like the tens place or the hundreds place. Once we've chosen our target, we can choose a method of simplification. Let's begin by using one of simple logic. Consider we're looking to round 12 to the nearest 10. We know that the tens that are closest to 12 are 10 and 20. So we need to consider which 12 is closer to. Obviously, we'd say 10, so our answer would be 10. Let's do another example. With 36, we know that the nearest tens for 36 are 30 and 40. We can tell that 36 is closer to 40 through simple logic. What about rounding a number like 85 to the nearest 10? The nearest tens are 80 and 90. So where should you go? Since 85 would be considered at the halfway mark, it's a bit of a gray area. There is a solution to this though. In mathematics, it is always considered to round up. Think about it like this. If someone asked you to round up $85 so they could pay you, what would you say? 80 or 90? Exactly. With this logical reasoning or mental number line, it feels more natural to round up numbers, though we can follow a more systematic way to round up so that we can apply it to a plethora of situations. So let's see how we can do this with rounding to the nearest tens. Let's look at the previous examples. When we are looking to round up 12 to the nearest 10, we need to find the tens place, because that's what we're looking to round up or round down. If you're not familiar with finding the tens place, you can check the video in the card to freshen up on your place values. We can use this chart that I often use with my students. This has digits that shows us what will round up and what will round down. 5 and above rounds up, 4 and below rounds down. Now for 12, we need to locate the tens place. The tens place is where the 1 is. So when we find it, we need to look at the digit immediately to its right, which is the 2. Now looking at the chart, we see the 2 rounds down. So that means that 2 and any numbers to the right become 0, and the 1 and any other digits on the left side remain the same, giving a final answer of 10. Let's do a few more examples to solidify how rounding down works. Now to look at 134, we know that the tens place is where the 3 is located. So looking to the number immediately on the right, we get 4. According to the chart, 4 rounds down. So we know that 4 and any other numbers on the right become 0, and 3 and any numbers on the left remain the same, giving us a final answer of 130. For one more example, we see 44.6. We know that the leftmost 4 is the tens place. So immediately to the right, we get 4 again, which we know from the previous example rounds down. So the rightmost 4 and all the numbers on the right become 0, and the leftmost 4 and all the numbers on the left stay the same. And we get a final answer of 40.0 or just 40. Now that we know how rounding down works, we can look at rounding up. Going back to the previous example, we look at 36. 36 being rounded to the nearest 10, we find the tens place, which is 3, and check the digit immediately to its right, which is 6. We then see that according to the chart, 6 rounds up. This means that the 6 and all the other digits to the right turn to 0. Now when a number rounds up, the place value that you're rounding to gets 1 added to it. So over here, we would add 1 to 3, which makes it 4. All the digits to the left stay the same unless something carries over. This gives us a final answer of 40. Let's do a few more examples. Look at 397. Now we know where the tens place is. It's the 9. Immediately to the right, we have the 7. And we can see from the chart that 7 rounds up. We know that 7 and any digits to the right of 7 become 0, and 9 gets a plus 1. Now when we plus 1 with 9, we get 10, right? So we do what we do in addition. We leave the 0 below and carry the 1 to the next number, which is 3. 3 plus 1 is 4, so we get a final answer of 400. Now 15, we know where the tens place is, it's where the 1 is. Immediately to the right, we have 5. According to our chart, 5 rounds up because we need to get that bag. So 5 and all the digits to the right become 0, and 1 gets plus 1 to it, so it becomes 2. We get a final answer of 20.0, or just 20. Alright, so let's do some practice questions. And remember, just because we did rounding to the nearest 10 doesn't mean that rounding to the nearest 100 and 1000 is different. When you round to the nearest 100, you look at the hundreds place and check the number immediately to the right to see if it rounds up or down. When it's rounding to the thousands, you look at the thousands place and then check the number immediately to the right. It's pretty straightforward. So give it a go and we'll continue when you're ready. Okay, so for the first question, we have 45. Now, the tens place is 4 and immediately to the right is 5. We know that 5 rounds up, so 5 becomes 0 and 4 gets a plus 1, making it 5. We get a final answer of 50. The second question for rounding to the nearest 10 is 63. We know that 6 is in the tens place and 3 is the number immediately to the right. We also know that 3 rounds down, so 3 becomes 0 and 6 stays the same. The final answer being 60. Now for rounding to the nearest 100, we find the hundreds place, which is 1. Immediately to the right, we have 5. So we know that 5 rounds up, meaning 5 and everything to the right becomes 0, and 1 gets a plus 1. So we get a final answer of 200. Now for the next one, we have 94. Now our hundreds place is technically empty because there's nothing there. The highest we have is the tens place. So immediately to the right of the hundreds place, we have 9. 9, we know from the chart, rounds up. So 9 and 4 become 0, and the hundreds place gets a plus 1. It's currently empty, so empty plus 1 gives you 1, giving us a final answer of 100. Okay, for rounding to the nearest 1000, we have 8,642. Now we know that the thousands place is where 8 is. Immediately to the right, we have 6. We know that 6 rounds up, so 6 and all the numbers to the right become 0, and 8 gets a plus 1, making it 9. And we get a final answer of 9,000. One last question before we continue. 12,034. We know that the thousands place is 2. Immediately to the right we have 0. So obviously this one rounds down. So 0 and all the digits to the right become 0. So 12 gets a plus 0, leaving it as 12, giving us a final answer of 12,000. Now the rounding that we've done so far isn't too common in exam questions. However, it is a fundamental skill to the more common questions, which are rounding to the nearest whole, rounding to a number of decimal places, and rounding to a number of significant figures. We'll start with rounding to the nearest whole. Now, rounding to the nearest whole means that we are taking a decimal number and rounding it to the ones place so that we can get rid of all the decimal places. Let's try this with 1.4. Now, we locate the ones place and check the digit immediately to its right. In this example, it's 4. Checking the rounding chart, we know that it rounds down. So we change the 4 and any digits to the right to 0, and 1 remains the same. So we get our final whole number of 1, or 1.0. Let's do a couple more examples. Looking at 24.7, we identify the ones place as 4. Immediately to the right, we get 7. We know that 7 rounds up, so 7 and any digits to the right become 0, and 4 gets a plus 1, making it 5, giving us a final answer of 25. In the next example, we have 104.68. We know that 4 again is in the ones place, and immediately to the right we have 6. 6 rounds up, so 6 and the digits to the right side become 0, and 4 gets a plus 1, giving us a final answer of 105. You know the drill by now, we're going for practice questions. Take a moment, continue when you're ready. Okay, so for the first one, we have 4.5. We're rounding to the nearest whole. We know where the ones place is, so immediately to the right, we have 5. We know that 5 rounds up, so 5 becomes 0, and 4 gets a plus 1, making the final answer 5. For the next one, 7.08. 7 is the ones place, and on the right side we have 0, so we know that it rounds down. So 0 and all the digits on the right become 0, and 7 stays the same. So our final answer is 7. Now for 0.635, our ones place is empty, but on the right we have 6. The 6 tells us we have to round up, so 6 and all the digits on the right side become 0, and 0 gets a plus 1, which makes it 1, giving us a final answer of 1. Now we'll look at rounding to a given number of decimal places. This is usually between 1 and 3 decimal places in the science subjects like physics, chemistry, and biology. So the final answer should have a maximum number of decimal places as specified in the requirement. Let's put this into practice. If we have a number like 6.83956, that's a mouthful, and we're rounding this number to one decimal place, we take the first decimal place closest to the decimal point, which is 8 in this example. Now we look at the number immediately to its right, which is 3. Then we proceed as normal. 3 rounds down, so it and all the digits to the right become 0. Since it rounds down, 8 and all the digits to the left remain the same, giving us an answer of 6.80000. We can drop off the extra zeros and leave a final answer of 6.8. We can use the same number for 2 decimal places. We identify the first 2 decimal places closest to the decimal point, which are 8 and 3. So we check the number immediately to the right of 3, which happens to be 9. This tells us that it rounds up, so 9 and all the digits to the right become 0, and 3 gets a plus 1, making it 4, and all the other numbers stay the same, giving us a final answer of 6.84. Now finally, for 3 decimal places. We locate the first 3 decimal places that are closest to the decimal point, which are 8, 3, and 9. Then, checking the digit immediately to the right of 9, which is 5, to see if it rounds up or down. Looking at the chart, we see that it rounds up. Thus, it makes 5 and all the numbers to the right 0, and adds 1 to 9, which makes it 10. Now, we've seen this before, so we leave the 0 where it is, carry the 1 over, 1 plus 3 is 4. So now we have a final answer of 6.840. We can write this as 6.84. Both will be seen as correct, so don't be disheartened by it being 2 decimal places. You did your job correctly. Now let's look at some practice questions. Take your time. Okay, so for the first one, we're going for 1 decimal place. We see that the first decimal place is 0. Immediately to the right, we have 8. We know that 8 rounds up, so 8 and everything on the right becomes 0, and 0 gets a plus 1, making it the final answer 2.1 and all of the zeros, dropping them off to get us a neat 2.1. The next number, we're going for 2 decimal places. Now, we know our 2 decimal places are 4 and 0. Immediately to the right of the 0 is 3, and we know that 3 rounds down. So, 3 and the digits on the right become 0, and 0 and all the digits on the left stay the same, which gives us a final answer of 13.40 or 13.4. Now finally, we're going for 3 decimal places. We see that our first 3 decimal places are 8, 1, and 5. So immediately to the right of that, we have 7. We know that 7 rounds up, so 7 becomes 0, and 5 gets a plus 1, making it 6, giving us a final answer of 0.816. Now we can take a look at significant figures. Significant figures are considered as natural numbers and zeros that are between 2 natural numbers. In this example, we can try to find out which of these figures are significant. Starting with the first example of 1200.000, we see that our first digit on the left is 1, which is a natural number, meaning it is significant. You have 2 and 2 more zeros, which are also significant. Now, on a technicality, all of these digits are significant, but in regards to what is necessary for the number to remain itself, we see that the first 4 digits are significant, and if we are asked for 5 significant figures, we can add a decimal place on top of that. For the next example, we see 109.030. Over here, the first digit on the left side is 1, which is significant. The 0 in between the 1 and the 9 is also significant because it is sandwiched between them. This is the same for the 0 between the 9 and the 3. Now the 0 after the 3 is technically insignificant. This is for the same reason as we discussed earlier. For the last example, we have 003.056. Now, the first 2 zeros over here are insignificant. When we remove them, nothing changes. And since 3 is our first natural number, it is our first significant figure. So we have 3, then the 0, which is sandwiched between 3 and 5, is also significant. 5 and 6 are significant as well. So I hope this gave you a better understanding of how to identify significant figures, because that's going to be very important moving forward. When you encounter significant figures in an exam, you're almost always likely to be asked to round to 3 significant figures. It's a very common standard practice, from what I've seen at least. So let's go over examples to figure this out. Looking at the number 938,721, to round it down to one significant figure, we start with 9. Since 9 is the first significant figure, we can look immediately to its right to see if we need to round up or round down. 3 rounds down, so 3 and all the digits to the right become 0, and 9 stays the same, making our final answer as 900,000. If we were doing this to 2 significant figures, we would take 9 and 3 because they are the first 2 significant figures. So looking to the right of 3, we see 8, which we know rounds up. Changing 8 and all the digits to the right to 0 and giving a plus 1 to 3, making it 4, giving us a final answer of 940,000. Doing this to 3 significant figures, we look at 9, 3, and 8. So we check the 7 because it's immediately to the right of the third significant figure. 7 rounds up, so 7 and all its compatriots to the right become 0. 8 takes a plus 1. So we have a final answer of 939,000. As you increase in significant figures, you increase your accuracy. So 3 significant figures is fairly accurate. It's good to make estimations. And usually when you're asked to give answers in 3 significant figures, it's relevant to your calculations moving forward. So pay attention, read your instructions carefully, see how many significant figures are needed, and leave your answers to that when it's applicable. Now let's do some practice questions. Take a moment, continue when you're ready. Okay, so for our first question, we recognize that 4 is the first significant figure. So we look to the number immediately to the right, which is 8. Now we see from the chart that 8 rounds up, so 8 and all of the numbers to the right becomes 0, and 4 gets a plus 1, making it 5, giving us a final answer of 50. For the second question, we have to round to 2 significant figures. Now, looking at this, we see 0.01. 1 is our first significant figure, so 1 and 9 are our first 2, meaning that we have to look at 4 to see if it rounds up or down. Now 4 rounds down, so 4 and 1 to its right becomes 0, and 9 doesn't change, so it gives us a final answer of 0.019. For our final question, we need to round to 3 significant figures, so we ignore the 0.0 and look at the first significant figure, which is 1. Then we see our next 2 significant figures, which are the zeros. To its right, we have 1. 1 rounds down, so it changes to 0, and the digits on the left remain the same. So we get a final answer of 0.0100, which simplifies to 0.01. So for notes, you've got the rounding chart, obviously. I've used this in classes as low as grade 2, and it's helped students tremendously. I'm telling you, it will do you some good if you're really struggling with this or you're just starting to get the hang of it. It's also really easy to draw because all you do is write the numbers in descending order and put a line between the 5 and the 4. It's important to practice so that you internalize this and do it really quickly in exams. Saving time is key, especially with these simpler concepts. Now, you just need to remember that when you round to the nearest whole number, that means you're rounding to the ones place. When you're rounding to a given decimal place, it means that you're selecting decimal places of that amount closest to the decimal point. And rounding to significant figures is rounding to a given number of significant figures. Here's a definition to help you find significant figures in numbers. You can find a printer-friendly image of these notes at the link in the description. Well, that's it from me. Thank you for watching, and I hope this video was of help to you. Take care, and I'll see you next time in the classroom.